Okay, then welcome back, everyone, for what is now our third NSF-funded OPAM webinars, third webinar in our webinar series. So today, I don't really have very much OPAM announcements to give because all the abstracts have been submitted and the professional development ward, we're all working on that already. So for the conference itself in Denver in November, then just stay tuned for updates in your email. Instead, today, it's my pleasure to introduce Jason Geller, who directs the Human Neuroscience Lab at Boston College. And he's going to walk us through how to make beautiful and reproducible manuscripts using R in Quarto. So without any further ado, I'm going to go ahead and pass the floor over to you, Jason.
Awesome. So am I able to access the chat at all before I begin? I don't know if I see it anywhere. So if you wouldn't mind, so first off, I want to thank the OPAM committee for inviting me to talk about reproducible manuscripts. I'm super excited to talk about alternative ways that we can write documents that incorporates open science practices and principles. So hopefully folks will be able to kind of get a launching pad from this talk here. But just some logistical things first. So I did create a website for this workshop, and I have the URL at the top here. And if you can copy and paste this into the chat, or can I? Oh, okay, I have the chat, so never mind. Okay, I was like, where is it? Sorry, I have this big ultra wide screen and I'm condensing it, so like things are not where they're normally for me, but I have posted the URL. So everyone can follow along with my presentation today. So all of the slides that I'm using are hosted on this website and all of the exercises as well. So if you want to go back later on and revisit the slides or do some of the exercises on your own, I'm not going to walk through all the exercises. You can do so. I've also linked the GitHub repository for this workshop as well. So at the bottom of this landing page, you can click on the GitHub repository and it has all of the slide code. So if you want to reuse it, repurpose it for your own needs, and you want to give a reproducible manuscript presentation on your own, please feel free to use my materials. They are for you to use. So just wanted to get that out of the way. You can also take out your cell phone and you can scan this QR code to get access to the materials as well. So there's kind of several learning objectives that I want folks to get from this workshop here and have those laid out here. But essentially what I want everyone to walk away with is basically how to set up a reproducible folder and project structure. Regardless if you are using this for a manuscript, every project that you do should have some type of individual modular project folder. That is very important. Hopefully by the end of today, you'll know how to use Markdown syntax to format and stylize your text when writing. By the end of today, you'll be able to insert code chunks into your document and execute those code chunks and also reference those in text. I'm going to show you how to insert references and citations using Zotero. So you'll be able to cite in your manuscript. And then lastly, I'll show you how to render your Quarto document to various formats. So you'll be able to output or render a document to whatever format that you would like. So these are the core learning objectives for today. So now that I got that out of the way, let's go ahead and kind of jump in to the main talk. So again, all the slides that I'm going to be using are located on this website. So I'm going to start off with the introduction first, and I'm going to put these into full screen. So hopefully everyone can see my slides. Please make a note in the chat if you cannot see them, and I'll try to do something about that. All right, so it's probably not new knowledge to the folks in attendance here that we're in the midst of what Samin Vazir has called the credibility revolution. And I particularly like this terminology because it evokes positivity, it evokes optimism, it evokes hope. As compared to some things like, the replication or reproducibility crisis, or the often used term that science is in a crisis of confidence. Those evoke, pessimism and bleakness, and I don't like to use that terminology. I prefer the credibility revolution because a lot of great things have arisen during this time. It's not been all bad. And one thing that's arisen from the credibility revolution is the open science movement. So for the folks that don't know, open science is this umbrella term that encompasses a lot of concepts and ideas. It encompasses how we share or disseminate our work. It encompasses our core values as scientists. And it also encompasses how we do our research, our workflow. In a nutshell, it's about being open and transparent at every single stage of the research process. And there's 3 key guiding principles to open science. One is open access. So this involves making all of your research free and accessible to every single person that wants it. So if your mom or your grandmother wants to look at your research, they should be able to have access to that research. And there's lots of ways that we can apply open access to our work. There are lots of great repositories that exist, such as the Open Science Framework and GitHub, that you can put your research on. We can also publish our work in open access journals. Now, the caveat to that is that some open access journals cost money. And sometimes we don't have grant funding to publish in open access. However, there are several really great diamond open access journals that allow you to publish for free. So those are things that you should take into consideration. Even if you don't publish in open access journals, you can publish your work on preprint servers such as PsycArchive. So a preprint is something that you would post before you submit a paper, but you can also put things like postprints on the preprint servers. So after the paper has been published, you can just take that paper that's unformatted and post it on a preprint server. This way, you can share that version and everyone can have access to it. Another key principle of open science is open data. So this involves making sure that all of your data is accessible to everyone. So they can verify that data and they can rerun those analyses or have access to that data to do whatever analyses that they want. One thing that I hate more than anything is to read a paper and see that the data is available upon request. Because chances are when you go to email them, they will ghost you, you won't get a response from them, and you won't get that data. Just post the data in some type of repository so people can have access to it. And then lastly, one of the key principles of open science is open code. So all of the code that goes into your analyses, that goes into your figures, that goes into your tables should be made accessible and open for everyone. So related to this is open software. So in order for you to have open code, you need to use open software that's free and accessible to everyone. So programs such as R and Python are free and accessible to everyone. Sorry for folks that use MATLAB, but most people don't have access to MATLAB because it requires a subscription. Same goes for SAS, same goes for SPSS. So we really need to think about the types of software that we're using as well in order to kind of encapsulate these key principles. So one way that we can put these practices or these principles into practice is through reproducible manuscripts. So what does it mean to have a reproducible manuscript? Well, what it means is that I can take every single component of an article. So that means the text, the code, the citations, and I can give it to someone else and they can reproduce that article. Everything that goes into that article is reproducible. Exactly. All the statistics, all the tables, and all the figures. That's what I mean when I say reproducible manuscript. And today I'm going to talk about how we can create a reproducible manuscript in R using Quarto. So what I would like folks in attendance to do is just take a couple seconds to think about what your typical workflow is when you're writing a manuscript. Like, what are the steps that you take when you're writing a manuscript? What you probably do is you fire up your statistical programming software. So you fire up R, you fire up Python, you fire up MATLAB, you fire up SPSS, and you run your analyses. That's step number one. Then what you do is you open up a Word program or a word processing program, such as Word or Google Docs, and you start writing. Then what you do is you go back to your statistical program, you go back to R, you go back to Python, and you copy and paste the results that you have there, and you put them into your manuscript. And then you do the same thing for your figures and tables. So here you might just do your figures and tables in Excel, and then you might copy and paste from Excel. So now you have multiple different now you have multiple softwares open, and you're copying and pasting between them, right? And then what you might do is you might manually format your results and citations. So you might go to your statistical program, and you might you might run an analysis, and you might copy and paste that F value, you might copy and paste the P value into the manuscript, or you might just actually manually write in those results here. So this is probably what your typical workflow is. I'm not going to show this video just for the sake of time, but I do recommend watching this video because it's too real. I think that this is an accurate representation of kind of the workflow that we use when we're doing research. So I definitely recommend watching this video if you have some time. I think it's great. But overall, this workflow is not reproducible. Right. And one of the main problems with this workflow, and hopefully this is not going to be triggering to some people, but the main problem with this is Word, right? Or Word adjacent type programs. So as the famous philosopher T. Swift said, "Hi, it's me, I'm the problem." So Word and Word adjacent type programs are problematic. They provide an impasse to reproducible research. And I'm sorry for all the people that love Word here and that write all their manuscripts in Word, but I absolutely hate Word. It's one of the worst programs ever. So on the right-hand side here, I have an example of a Word document. So this is something that we're probably all used to seeing, right? We have some lovely text here. We have some formatting. We have a bold text. We have italicized text. We also have a nice list here, right? This seems really simple, right? We write our document. We send it to our colleagues. Everything is great. But has anyone ever looked inside a Word document, like gone into the internal structure of a Word document? So it looks something like this. This is what a Word document looks like if you look at what's the underlying code of that document. It's a whole bunch of formatting, and the text is buried deep down inside. So we can kind of see that the text that we wrote is here, right, deep down further in the code, right? This is my Word document. And then, we have to search for the other parts of the text here too. But this brings forth several issues that I want to talk about. The first issue I kind of already talked about is that the Word document is a compressed folder with lots of files, right? So your text is buried in with a lot of formatting information. There's not a one-to-one correspondence between the code that's written or the text and the code that produces it, which is problematic. Another issue is that it's not reproducible. Right? So code is divorced from writing. I don't know about you guys, but it's rare for me to see a Word document that also encompasses the code that is used to generate the analyses, the figures, the tables. It is very rare. If you were to give me a Word document with figures and tables and analyses, I could probably reproduce it. It might not be perfect. There might be things missing, but it's going to be really hard for me to reproduce it. Again, I can put in all of my effort to try to reproduce it, and I could probably do it, but it's going to be difficult to do it. Another issue is that it's difficult to maintain. As I talked about before, sometimes we're using several programs in conjunction with the manuscript proper. So we're using R, we're using Excel, and we're copying and pasting from all of these programs into the Word document, right? So what's going to happen here is that errors are going to creep in, right? So we're going to say that p-value is greater than 0.05 when it's less than 0.05. We are going to have nonsensical t-values, et cetera, et cetera. So it becomes really difficult to maintain. And then there's also issues of what you should share, right? So there's a lack of transparency. Do you include the Elmer function or the Elmer syntax that you use to fit your multi-level model? Do you leave that out? Do you include some code? Do you not include all code? Do you talk about pre-processing code? So again, it creates a lack of transparency because lots of stuff is left out. So these are several issues with Word and Word adjacent type programs that really present an impasse to reproducible research. So as scientists, what do we want when we're writing a manuscript? At least what do I want when I'm writing a manuscript? So I want to be able to weave text with code. This is called literate programming. I want to make sure that my code is closely connected to the text. I want to be able to automatically generate figures and tables. I hate manually tweaking figures. I hate manually tweaking tables. It just never goes well. I want to just be able to write some code that just generates the figures and tables that I want. I want to be able to render results in text. So I don't want to have to actually manually go into the text and manually put in the results. I want to just have it be rendered automatically for me. I want to be able to take some text and format it into a scientific paper. I want this all done automatically for me. I don't want to put in that work. I hate doing that. And also, you know, as scientists, we're not heathens. We want something that looks pretty, right? We don't want something that looks horrible and messy and unorganized. So yeah, we want something that looks pretty. And then also, importantly, we want something that we can reuse over and over and over again. The templates that we create, the code that we create, I want to reuse those to create other papers. So how are we going to do this? Well, I want everyone to say hello to Quarto. Hi, Quarto. So Quarto is an open source publishing system. It is new-ish. It's probably been around for maybe 4 years, 5 years. I'm not really sure. But it's a publishing system that allows us to create lots of really cool documents. And it's designed for reproducibility. When I introduce Quarto to folks, I introduce Quarto as our Markdown's little better brother. So for folks in here are probably really familiar with R Markdown. They probably have been using R Markdown for a really, really, really long time. And the good news is that if you know R Markdown, it's very, very easy to learn Quarto. They are very, very similar. There are some differences between R Markdown and Quarto, but for the most part, you can just start right in using Quarto. The syntax, a lot of the syntax is very similar. So it shouldn't be, a big learning curve to learn Quarto. And one of the main draws of Quarto is that it's essentially for everyone. And when I say everyone, I mean programmers. So if you use R, if you use Python, Observable, Julia, what Quarto allows you to do is, switch formats without hassle. So you can write R code and you can mix that with Python code, and you can use Julia code, all within the same document. So with a Quarto document, you can use all these different languages and render them into lots of different formats. And it's highly versatile. So you can use Quarto to create websites. So I created my website with Quarto. You can create blogs with Quarto. So a shameless plug. So I have a YouTube video here that basically walks through how to create a blog with Quarto. So if you're interested in creating a blog, an academic blog, you can go to that link and you can follow along and create a blog and a website. You can create books with Quarto. And if you haven't guessed it, I created these slides with Quarto as well. So Quarto is highly versatile. Now you might be asking to yourself, what the heck is a Quarto? So a Quarto is an old publishing technique where you take a piece of paper and you divide it into 4 quadrants, and then you fold it multiple times to get a book that has 8 pages. That's essentially what a Quarto is. Now, how does Quarto work? So this is going to be a high-level explanation of how Quarto works, but essentially Quarto works through a series of steps. So when we open up a Quarto document, it's a QMD file. And what happens is that we use knitr, which is a program in R that executes all of those code chunks in the Quarto document and creates what's called a Markdown file. Then we use pandoc that will take that Markdown file and it will render it to multiple formats, to whatever format you would like. And luckily, all of this happens inside RStudio, or it happens inside Positron if you use Positron. And it handles all of these interactions here. All we have to do is just render the document by pressing a button or typing in some code. So really simple and straightforward. So now that I've kind of explained Quarto here and hyped up Quarto, let's go ahead and start writing a Quarto manuscript. So before we begin, I have a little note here. So we're going to create a project folder for our manuscript. And I highly recommend during these kind of live coding sessions that you follow along with me. I think you'll get the most out of this workshop if you follow along with me. If not, you can come back and watch the video at a later time and follow along as well too on your own time. But I'm going to be opening up our studio and kind of showing you how to create a project folder here and going over kind of a Quarto, the components of a Quarto document here. But I have a little note here. You should always create a project folder for whatever you do. So even if you're not using this for a manuscript, for whatever project you're doing, always create a project folder. I have known people that will just open up our studio and all of their projects will just be in the same session. Please don't do that. That's bad practice. Just create a new project folder for everything that you do. I promise it will make your life a lot better. So luckily in our studio, they have a Quarto manuscript project type that we can use, and that's what we're going to use today. And it's very, very simple. And I'm going to walk you through how we do that. And for the folks that use Positron, it's also very simple. So Positron is pretty new. I don't know how many people are using it. If I could, I would be using Positron today, but I think that most people are familiar with RStudio. So we're going to stick with RStudio today. So I'm going to go to R right now. So I'm going to open that up and I'm going to walk you through how to create a project folder for this workshop. So can everyone see my RStudio session? Can you give me a thumb up?
Yeah, the bottom of the screen is a little bit cut off though, huh?
Okay, let's see here. Let me just do this. There we go.
Yes.
Is that better?
Yeah.
Awesome.
Perfect.
Awesome. All right. So what we can do to create a manuscript project folder. So in RStudio, let's see here, since I'm just going to like hover over this. What we could do is go to File, New Project. And then let me move this screen over. There we go. You can go to New Directory, and what we're going to do is go to the new project type. Excuse me, let me go back. We're not going to go to the new project type. We're going to go to the Quarto manuscript type and click on that. And then we're going to call this OPAM. Let's do OPAM talk. And then we're going to save this to documents. And then we're just going to create a project here. And after you do this, it should open up a new session. And what you'll see here is a number of files that are produced automatically. So there's several files here. But before we begin, we need to make sure that we have all of the packages that are needed for this workshop. So what we're going to do here is we're just going to copy and paste this into our console. So we need the Palmer Penguins package, we need the Quarto package, our Markdown and Tidyverse package. So let me go ahead and just copy this, and then we're going to copy this into the console and just run that. There we go. Go back here. And then we also need TinyTech. So if you're going to be rendering your document to a PDF, I highly recommend TinyTech. So this is a lightweight installation of the popular LaTeX packages. But again, it's not going to take 9 hours to download. It only downloads the necessary packages. I'm not going to install this because I already have it on my system. But if you'd like a PDF document, you should install TinyTech. But it's going to take a while, so I recommend installing that now if you haven't already done so. All right. So now let's go back to our project folder. Let me get this here. I'm just going to go like this. All right. So as I said before, when you create this project folder, there's already several files that are produced automatically, which are going to help you create your manuscript. The important one here is this index.qmd folder, or excuse me, the QMD file, and that is presented here on the left-hand side. So this is automatically created for you. If you wanted to create a Quarto document that's not this one, you can do that as well. So in the upper left-hand corner, there's this little plus sign here. You can just go down to Quarto document, and then you can just create a document, whatever, OPAM 1.
Could I ask
And
you a
then,
question real quick,
yes,
Jason?
yep.
Some people in the chat are wondering where to get the libraries from, specifically if they aren't available.
So Tiny Text should download all of the library. Are you talking about the libraries like the packages?
Yeah, I think if you go back, you had I think the Palmer
Yep.
Penguins and Quarto and
Yeah,
or
so
Mark.
all of these can be downloaded with the library. So you can just go to packages and then install, and then you can download Palmer Penguins, and then you can also download Quarto if you don't have them.
So it's in the packages tab
Yep,
there.
the packages tab. Yep.
Okay. If anyone has any more questions, then just let me know and I'll interrupt
Yep.
Jason again. But
Yeah.
otherwise, I'll just let you go.
Sounds good. So again, you can create your own Quarto document if you'd like. I recommend if you're just starting out, just to use a template that's provided by R, because it can get, you'll get started very quickly. So again, the important file that we're going to walk through today is this QMD file. And there's 3 important components to a Quarto document. At the top, what you'll see is what's called the YAML, which stands for yet another markup language, if you're interested. And the YAML is denoted by these 3 hyphens at the start and at the end of the YAML. And it consists of a bunch of key value pairs. And this is essential for, so what this represents essentially is the metadata for your document, as well as the rendering information. And it's a bunch of key value pairs. If you see a bunch of key value pairs, it's most likely the YAML for that document. But you can see here we have a title key, and then we're calling this OPAM talk. You can change this if you like. We also have an author's key with the name, Nora Jones. I could just change this to Jason Geller. And then affiliation, and then the roles that the person took while writing the document, if that person is a corresponding author on this document, and then also the bibliography information, so the file name here. And then additionally, we have some text, right, that we write with some formatting here, and we also have a citation here. And then we also have a code chunk here, which is going to do the addition 1 + 1, and then it's going to output some type of result. So those are the main features or components of a Quarto document. Now, there's 2 ways that we could view this document. We can view this in the source mode or the source editor, and this will display the raw Markdown syntax. As you can see, there's really no formatting here. We can also view this document using the visual component or the visual editor. So we can see here that now there is some type of formatting. And this is the what you see is what you get editor, essentially. So if you're really familiar with word processing programs like Word and Google Docs, I highly recommend you using the visual editor, because again, there's lots of useful features like drop-down menus, and you can also click on tabs that will do all of the formatting for you. So if that's something that you're used to using, I'd recommend using the visual tab to write your manuscript. Also, while we're writing our manuscript, there's an outline component here, an outline button that will show you the outline of the paper that you're writing with the different sections. In the bottom left-hand corner, there's also a section button here that allows you to navigate to certain chunks in your writing. So this is kind of just an overview of a Quarto document. And let's just render this document just to show you what it looks like. So I can show you kind of the one-to-one correspondence between what's written and the output. So to render your document, there's a little button at the top here called render. We could just click on that. And it's going to render the document in the viewer panel. So by default, the document is rendered to an HTML document. I'll show you later on how you can change that to render it to some other format like Word or a PDF. But this is what our document looks like. And if you've never rendered a document before, congratulations. This is your first manuscript that you've rendered. But what I want to highlight here is the kind of one-to-one correspondence. So we can see the YAML information, which is kind of the meta data, and the rendering information is at top, right? So we have the title here. We also have the author, the affiliation. And then what we see is the text part. So we have a header here, and then we have some text and a citation. And then we have some output here. So we have 2 here, which is 1 + 1. And then we have a reference section here. So this is basically Quarto document, a Quarto manuscript. And we're going to use this throughout this talk, and we're going to build on this, and I'm going to show you how to do different things. What I'm going to talk about next is Markdown syntax. Then we'll talk about referencing in the document. Then I'll talk about code chunks. So that's kind of the outline for the rest of the talk today. But before I begin, are there any questions that folks have? I saw that there was several messages in the chat. Is there any like big looming issues that need to be addressed before I go on?
So it looks like some people are having problems getting Palmer Penguins installed, but I don't think that's essential to be able to follow along today. Is that right?
No, it is not essential to follow along.
Yeah.
That is correct. There's one part that uses the Palmer Penguins package. That's weird that you can't load the Palmer Penguins package, but yes. We'll get back to that. We'll also have time at the end to answer some questions as well, right? So I can walk through some issues as well. All right. Let me go back to... So I walked through like a live demo of all of this, but there's also text and slides that you can follow along to at a later time if you want to. That kind of explains these things more in depth. So if you prefer to do that, you can look at that at a later time. So right now, what I'm going to do is I'm going to shift to talking about Markdown. So I'm going to click off of this, and then I'm going to go to the next section.
Yeah, and maybe you also have already seen the message requesting that you could maybe slow it down just a little bit.
Oh, okay, gotcha. There we go. That should work. All right, so let's talk about writing in Markdown. So what I'm going to be talking about is Markdown syntax. So when we're writing our Quarto document, we're going to use what's called Markdown language. And what Markdown is just basically a lightweight markup language that you can use to stylize and format your text documents. That's all that Markdown is. So what I have here on the left-hand side is an example of some Markdown code. So we can see here that we have these double asterisks, we have these underscores here. This is Markdown. And then we also have a list. And what this produces is this output here, right? So we have our italicized word, we have our bolded word, we have a list here, right? That doesn't seem too bad, right? What I really want to highlight is the one-to-one correspondence between the code and the output. And it's important to know that Markdown is the lingua franca to creating any kind of document. And if you've never heard of Markdown before, chances are you've probably seen it in the wild. So if you've ever posted a question on Reddit, Reddit uses Markdown, as you can see here. If you've ever posted anything on GitHub, if you posted a GitHub issue, GitHub uses Markdown. And recently I found out that if you use Discord, you can also use Markdown in Discord. So I was amazing and wowing my friends by using Markdown in a chat with them. So Markdown is used quite frequently in lots of different areas. And today I'm going to kind of just give you a sneak peek into some Markdown syntax, but there's lots and lots and lots of useful resources that you can use. In our studio itself, you can pull up a quick reference of different Markdown syntax by going to the Help menu. There's also lots of cheat sheets that are available that you can use. So I linked to one of those cheat sheets here. And honestly, I would recommend that you use the visual editor in RStudio or Positron, which allows you to actually see the Markdown syntax previewed. It allows you to use a whole bunch of drop-down menus as well as buttons to format your text. And if you're starting out, I would definitely recommend just using the visual editor. But I still want to go over Markdown syntax. So we can use Markdown syntax to format our text. And I have some examples here of some Markdown syntax and what that outputs. So we can use single asterisks on either side of a word or double asterisks, and that will italicize and bold our data. We can use the little caret symbols. We can use the tilde symbols to create superscripts and subscripts, as shown here. The double tilde on either side of a word will create a strike through. Then we can use backticks for verbatim code here. I usually use the verbatim code backticks when I am referencing a particular package or I'm referencing a particular function from a package. So that's when I'll use verbatim code. We can also use Markdown syntax for headers. So what I have highlighted here is a level 1 header uses 1 hash mark, and that would create a level 1 header. 2 hash marks will create a level 2 header. 3 hash marks will create a level 3 header, and so forth and so on. But let's go back to our document real quick, and I just want to highlight the headers here. So I'm going to delete all of this. So when we're writing a manuscript, right, we start off with our introduction, and that's usually a level 1 header according to the APA, right? So we have introduction, and then we might have a methods section, right? And then within the method section, we might have a level 2 header called participants, right? And then we might have something called stimuli or procedure, and these are all level 2 headers here, right? So this is how you would do that in this document here. So this is in the visual editor, and we could see it automatically created. But if we go to source, we can see that we've included that Markdown syntax here, right? So let's just go ahead and render this document and see what it looks like. So again, we have our document here, and we have an introduction header, we have a method section, we have participants, stimuli, procedure, and so forth and so on. So that's what we can do with the hash mark symbol. Let's create headers. We can also create block quotes using this block quote marker here. And here I've kind of rickrolled everyone here, but this syntax will produce this block quote. We can also include math in our Markdown document. So we can include inline math. So here what we would want to do is just use the $sign on both sides, and that will create some inline math, so Pythagorean's theorem. We can also output centered math. And here we use the double $sign, and that will center the math. We can also include formulas, equations, and also mathematical symbols. And what's really cool here is that you can use LaTeX within the Markdown document. So if you have a complicated mathematical formula or equation, you can just take the LaTeX formalization and you can input it into our Markdown document or your Quarto document, excuse me. So it's really cool what you can do with math in Quarto. You can also create lists in Quarto. And here we just use the little hyphen symbol, and this will create an unordered list as what's outputted here. You can create an ordered list. Here, this is just a shorthand to get an ordered list by just using ones here. So this will produce an ordered list. You can also just use 1, 2, and 3 to order your list. However, it's very important to know that spaces are important. So you need to have 4 spaces to create sublists or nested lists. And then, as I said already about a tip, you can use 1, but this only works in the source editor. This will not work in the visual editor. The visual editor will just number your lists numerically. You can also include tables into your document. So this is kind of gnarly code here, but this will produce this table here. So no one has time for that. So instead, what I recommend is just using the visual editor. There's actually a table, insert table feature, and you can just insert a table directly into your document. And there's also a website called Table Generator, which will allow you to create a table and it will produce the Markdown syntax. So sometimes you might have a more complicated table, and the Table Generator might be helpful in that regard. You can also include links into your Markdown, your Quarto document. So what I have here is some code for hyperlinks. So to include a hyperlink, you have to use the brackets and then you name it. And then in parentheses, you put the URL, and that will create a hyperlink for you to click on and navigate to. You can also list URLs directly. You can use the angle brackets and just input the actual URL in there. And then you can also hyperlink to other places in your document. So here I'm using the brackets, and then I'm also referencing a section header with the hash mark, and then that will allow you to navigate to other places in your document if you do that. You can also take a URL with an image and you can insert that directly into your document. Here I'm just using an image of from Palmer penguins, but in order to embed an image, what you need is the exclamation point, and then you need to have a name for that in brackets, and then in parentheses you just put the URL in there, and that will allow you to embed an image into your document. And then probably my favorite feature of Quarto are these things called callout blocks. And callout blocks are allowed to be interwoven into your text. And what they do is they kind of interrupt the flow of your text. So it might be a definition of something, a warning, or a side note. And they can be interactive and they can be collapsed and opened, but this is only if you render to an HTML. This is kind of an example of a callout block, but there's 5 different callout blocks that you can use. So you can use a note callout block, right? So here there are 5 types of callouts. So note, tip, warning, and caution, and warning, caution, and important. There's a warning block. This is important block, a tip block, a caution under construction block. What I use these callout blocks for is to kind of just provide myself with self-deprecating comments, like, oh, this section really sucks, or this section needs a lot of work. So I really like these callout blocks. So now what I want to do is I want to go back to our Markdown, and I want to highlight how we can take some text and we can apply Markdown syntax to it. So what we're going to do is we're going to get some text from the website. So let's go back to the website here. And then what we'll see if we navigate down to the exercise portion, I have this paragraph here. And what we're going to do is we're going to try to take this paragraph and we're going to try to make it look like this document right here.
So maybe
let's go
before
ahead.
we move much further, there was a couple questions in the chat about how to get the viewer to work.
Yes.
How to get the go from the code to actually see what the page looks like. So is there anything that you have to do to set that up?
Yeah. So what you can do, so what happens normally is that when you render the document, it'll open up in a web browser, but you can have it open up in the viewer panel by going into your RStudio session, and there's this little cogwheel here. Just click on the little caret symbol and just type or just select preview in viewer pane. And that will allow you to view the document in RStudio instead of it opening up in a browser.
Awesome. So if there's any more questions from the audience, then yeah, please keep putting it in the chat.
Awesome. So yeah, so let's go ahead and let's just copy this text here. So you can just click on this copy button here, and let's copy it into our Markdown Quarto document that we are creating. So I'm just going to copy and paste this. So this is what the text that I just copied looks like in our Quarto document here. So I'm going to put this on the side. So let's go ahead and render this document as is, and let's see how it looks like. So it should not look like what I have depicted there, but let's just do it anyways. All right, so we see some text here. This is rendered as a document, and it looks nothing like this here. So how are we going to convert this text to something that looks like this? Well, what do we notice about this text here? Well, what we see is that there's some headers here, and they look like level 1 headers. So let's go ahead and just put level 1 headers for Meet Quarto and Meet the Penguins. So I'm in the source mode, so I'm going to show you Markdown syntax to do this. And I'll also flip to the visual mode too, so you can see it live too. So if you remember, to create a level 1 heading, we need to use the hash mark. So 1 hash mark is a level 1 heading. So I'm going to do that for both Meet Quarto and Meet the Penguins. So let's go ahead and just render that document, see what it looks like. All right, so it's starting to take form. It's starting to kind of look like this example here. So now we have some level 1 headings here for Meet Quarto and Meet the Penguins. So what are other things that are missing from this text here? Well, we see that Palmer Penguin seems to be hyperlinked. So let's go ahead and hyperlink that in our document here. So if you remember, to hyperlink something, we have to use the brackets. So we're going to do that. And then we're going to use the we're going to insert our URL into this here. So let's go ahead and do that. So on the actual website itself, I have a whole bunch of links. So we can actually just create, we could copy this link here and then copy it into copy it right here. There we go. So we've copied this into our brackets. So let's do this. All right, so let's go ahead and render this document again. So we've rendered the document, and now we see that the Palmer Penguins package has been hyperlinked here. Awesome. So again, starting to take shape. So what do we notice here about under Meet the Penguins? So we see that there looks to be information spread over 2 columns. So I didn't go over how to create columns in a document, but you can do that. So I'm going to walk you through how to do that in 2 ways. So what we have to do with an HTML document is use these things called div fences, which allows us to style a document a particular way. And they have a some columns code that we can use to spread our information over 2 columns here. So in order to do that, we need to use quadruple colons. And then we need to use these curly brackets here. And then there's a function called dot columns here. So that's going to set up a container for columns. And then what we're going to do is this triple colons here. And then we're going to do the curly brackets. And then we're going to do columns width here. And then we're going to do 50%. So this is not going to take up the whole column, just 50%. And then what we can do is we can add this information. So it's already there. This is the text. And then we're going to close off this column. So this is just going to be one column that we have, and then we have to create another column. So we can just use the triple bracket, the triple colons, and then we're going to do dot columns width equals 50%. And then we're going to insert the image that appears here. And what we're going to do is we're going to use this URL that's on the web page. We're just going to copy that. And if you remember how to insert a image through a URL, we're going to use the exclamation point. And then we're not going to call it anything because there's nothing here referencing that particular picture. And then we're just going to use the, why is this not copying? There we go. And then we have to close this off. So these are going to be our 2 columns. And then because we started a dot columns, we have to close that off. So this will allow us to create a multi-column document rendering to HTML. So let's go ahead and just render that document. Let's see, that's not right. Let's see here, did I do something wrong? Did I spell something wrong? There we go. So I had an extra S here. So it should be dot column, not dot columns. So now we have a document that looks like this example here. So again, this exercise was to show you kind of how to apply Markdown syntax to a particular document to stylize it. But this is for rendering to HTML. This won't work if you render to something like PDF or even a Word document. So what I'm going to show you how to do is just create multi-column document using the tables function. So I just deleted that. So let's go ahead and go to the visual editor and just insert a table. So we're just going to insert a table with 2 columns. So 1 row and 2 columns. And I'm not going to include the table header here. I'm just going to delete that. Delete the table. There we go. I'm going to put that down here. 1 row, 2 columns. So here we can just insert our text here. So I'm just gonna copy and paste this text again, and then put it into the first column. Why is this not copying? So just do that. Why is this? I'll just copy this. Why won't this copy and paste? That's so weird. I'm just going to do, this is some text because I can't copy it. This is some text. Copy this. I'm just going to go off that. And then what we can do is we could actually insert the Palmer Penguins link again. And I'm going to show you how to do this with the visual editor. So we can just do insert figure and image and then just use that. So create something like this. So when we render our document, it should be 2 columns. And I'm going to, let's do and see if it'll do an HTML. So yeah, so we have 2 column information now. So we have some text in one column, and then we have an image in another column here. So that's how you can do that with tables, but you can also do it with HTML div defenses if you are rendering to an HTML document. All right. So now what I want to do is I want to transition to talk about referencing in the document. So is there any questions about Markdown syntax before we proceed on?
So it looks like there's one person who's having some problems getting the render to go. I was trying to debug it myself, but I couldn't quite figure it out. Can you see the chat as well, Jason?
Let's see here. So I'll come back to that at the end. But if you open up a document, if you open up a project folder with using the Quarto manuscript project type, you should be able to just render it without any errors. It's also possible that something with Quarto or an earlier version of RStudio. But yeah, no, we can go back to that. I can definitely stay later to help people with some of the issues that they're having here. But so what I want to do is I want to transition to referencing. So when we write text, we want to be able to support our claims that we make. So we have to reference. So how do we do that in a R Markdown document? So in order for us to reference in our Quarto document, what we do is we use what are called BibTeX keys. And BibTeX keys have 2 main components. And I have an example of what a BibTeX key looks like here. So we have a cite key or reference identifier. And this could be anything that you'd like. And there's also key value pairs here. So such as author, title, journal, year, volume, etc. And we store these BibTeX keys in what's called a bib file, which stands for BibTeX Bibliography Database. And what a bib file is a whole bunch of BibTeX keys together. And I have an example of what that might look like here, right? So we have this at article, and then we have this at miscellaneous with some key value pairs. So what I wanted to walk through is kind of ideally how you'd go about referencing in your Quarto document. So as a first step, what you probably want to do when you're writing your manuscript is you want to find a reference that you need in your manuscript. And I'm recommending that you use Zotero. Zotero is great. Do not manually edit or manually enter in your references. Use Zotero. It's free. It's open source. It's wonderful. And they have a browser extension, which I'll highlight today, that allows you to save references to a folder and you can output a bib file that you can then use in your Quarto document here. But as a second step, you would save your reference to a Zotero library. Then you are going to cite the references in your manuscript using the @ symbol and then the reference identifier or the cite key. So you can do this in text using @ and then the reference identifier. You can also cite parenthetically using the bracketed citations. So you just put in brackets the reference identifier here, and that will allow you to cite parenthetically. We also need to make sure that we are referencing our bib file. So we do that in the YAML. So there's this bibliography key, and references.bib is the name of the file that's automatically produced when you create a project folder, a Quarto manuscript folder. But you can name this whatever you'd want or whatever you'd like. And if you want to know more information about citations, you can go to this website here. So what I'm going to do now is I'm going to walk you through how to reference in your Quarto document here. So I'm going to kind of just go through the process or this workflow and showing you how you can do that. So what we're going to do first is I'm going to open up Quarto on my system. So Zotero has to be open in order for this to work. So I'm going to open up Zotero. So hopefully you guys can see this. So I have my Zotero library open, and I'm going to create a folder called OPAM refs. I'm just going to create that in my library, and I'm going to just say create collection. So you can see here that there's nothing in my library here. So what I'm going to do is I'm going to find a reference, and I'm going to add it to this folder in Zotero. So let's go here. Let's see, what should I look for? I'm just going to go to my website and get, let's do this one. So let's find this DOI. All right, so what's great about this, so I have the Chrome Zotero extension, and this allows you to kind of reference automatically. Do I not have the Zotero extension here? So I'm gonna see here. So I'm gonna download this Zotero extension. There we go. So this allows you to kind of search the web and find references and automatically add things into your Zotero library. So let's go back to a page. Okay, so let's say that you're looking for a particular paper, such as this one, and what you can do is you can actually go to the extension and then click on Zotero connector. And then what it's doing, it's saving to this OPAM refs folder that I have saved here. And you can choose whatever folder you want it saved to. I'm gonna click off of that. So let's go back to Zotero. So we can go back to Zotero and look at that folder, and we see that that particular reference has been saved. So then what we can do here is we can actually export it to a bib file. So do better. I use Better BibTeX, and I recommend that you install that extension. It's not necessary, but what's really cool about Better BibTeX is that it allows your bib file to be updated. So every time you add a new reference into the folder, it automatically updates that bib file for you wherever it's saved. So by just clicking keep updated, every time you drop a new reference in, it'll update that. But let's go ahead and save this as a bib file. So I'm just going to call this references, and I'm going to save it to the OPAM folder. Let's see, where did I put it? There we go. So I'm just going to save that here as references, and it'll ask me probably to replace it. I'm going to say yes. So now I've saved this bib folder that I've exported from Zotero. So let's go back to our studio. So if we go to files, we can see that we have this references.bib folder, or excuse me, references.bib file. And we can see that that particular BibTeX key has been saved here. We have our reference identifier, and then we also have the other key value pairs here. So I'm just going to copy this because we're going to reference it. So what we can do here is we can reference this in text. So what I'm going to do is I'm going to write something and then cite it. So this article is not about penguins, and I'm going to parenthetically cite this. So if you remember to do parenthetical citations, you have to use the brackets. Let's do, what did I call it? There we go. So that is the reference identifier that I'm using. So let's go ahead and just render that. So this is our document. Let me go over there. And we can see that I have a parenthetical reference here in the text, and then I also have a reference section here. 2025, awesome. So even if you don't have something in your bib file, you can actually just reference on the fly here. So what's really great about the visual editor is you could just insert a citation. So let's say that you don't have something in your bib file and you want to cite it. I can just go to add citation and I can search for something. So I can reference an R package. I can reference something from a DOI. I can reference something from PubMed. But let's just go ahead and cite the Palmer Penguins package. And then let's just cite this in text. So this is about penguins. And we can also go to our references.bib and see that that's been added to our bib file, which is really great here. So let's go ahead and render this. Awesome. So we can see that we have a parenthetical reference or citation and then also a in-text citation. But what do people notice about this reference section here? So these references that are output are not in APA format. So how are we going to go make sure that our document is in APA format? Well, we have to use what's called a CSL, which is a citation style language, and they have one for the APA 7th edition. And I've saved that into the GitHub repository. So let's just go ahead and download that and use that in our document. So let's go back to, let's do this. I'm going to go to the main page. Let's go to the GitHub repository. And then I have something called apa.csl. So let's just go ahead and download that. Let's download it. So we can see that this is download APA CSL, and I'm just going to copy and paste that into, let's see here, where is it? I'm going to find that in there. I'm just going to copy this into the OPAM folder. So now we have this APL CSL, and I'm going to show you how to reference it in the YAML. So in our YAML, we can use a key called CSL, and we just have to call it APA CSL, and this will format your paper in APA format for the citations. So let's go ahead and render this document and see what that looks like. All right, so now we see that the parenthetical citation conforms to APA standards, as well as the in-text citation, right? And then our references are in APA format, right? You see how we did this automatically? So no more manually doing that by hand. So I think it's a pretty great feature of Quarto documents. All right. So now what I want to do is I want to shift focus to talking about code, but are there any questions about referencing that I can answer right now?
I think for now we're good. We have a nice question for the discussion, but I think we'll leave that for at the end and we can swing back to this. So I think you can.
Awesome.
Oh, we do have one question. Where was the insert citations again?
Ah, yes. So you can go to the visual editor, and then there's this insert button, and then go to add citation. So I could do insert and then add citation. And then just pull whatever. Even if you don't even want to add things by searching the web and adding them to a Zotero library, you can just build up your bib file using this if you wanted to.
Awesome. And then also, could you point out one more time where the APA CSL is for people to get?
So if you go to the URL for the workshop, I have a link to my GitHub repository. Click on that. And then it is in the repo here called APA CSL. You can also search for it online and it should come up.
And then also, could you quickly show us how to incorporate it into your RStudio again, which folder you put it into?
Yes. So what I did is I just downloaded this from there, and then I just copied this and then just put it into the folder that I'm using for this presentation. And I just copied that. And then now it's in the folder. Like that. So it has to be in your project folder to use it. And it has to be at the top of the root of the project as well. So make sure that you do that or I won't be able to find it. Let's do.
Awesome. I think we can keep moving on.
All right, so now what I want to do is I want to talk about coding in your document. Awesome. And primarily what I want to talk about are inserting code chunks and inline code in the document. So what exactly are code chunks? Well, code chunks are specific places for your code in your text. They're executable, so they produce results and you can run them. We usually place code chunks between text. And what these code chunks can do is they can print out output. So we saw where we did 1 + 1 and an output 2, or we can create new variables that we can then reference in our text. So here's an example of some addition in a code chunk that outputs this result. And then I'm assigning the object number to the addition of 1993 plus 2023. And then we see we get the number output here. So how do you exactly construct a code chunk? Well, what we need to do is we need to use backticks in our document if we're using the source editor. So 3 backticks at the start and 3 backticks at the end will create a code chunk. And I have an example of what that looks like here. And what we need is curly brackets as well. So we need to have the backtick and then the curly brackets, and then you can specify what programming language you want to use. Here, we're just going to use R, but it's pretty simple to also use Python as well, which I have outlined here as well. Then within each code chunk, we have these things called code chunk options, which are denoted by hash pipes. So I have some hash pipes here, and then there are some key value pairs here that we're going to use that I'm going to walk over and explain. So there's a whole bunch of code chunk options that you can use within your code chunk. This is only a handful of the options that you can use. There are many, many, many more. And I've linked to a website that gives you some more options as well. But you can use these code chunk options to evaluate the code chunk, to mirror the code and the results. You can set a code chunk option to continue processing even if there's an error. You can label your code chunk, which is good practice. So I recommend you always label your code chunk. You can also use options for your figures and tables. So you can caption it. You can specify the width and the height of those code chunks. So lots of useful options here. And I'm only going to go over a few of them, but again, refer to some of the links to figure out some more code chunk options that fit your needs. So there's 2 ways that you can specify the code chunk options. So if you want to execute each code chunk in the same way, you can include code chunk options in your YAML at the top of the document, as I have highlighted here with this execute key. And then you can do echo, eval, et cetera, But if you want to evaluate each code chunk differently, you can specify those options at the code chunk level. So within each code chunk, you can specify different options if you'd like. To insert code chunks, there's several options. You can type it out with the backticks and the curly brackets. You can also use the visual editor, and you can also use shortcuts. If you're on a PC, you can do Control-Alt-I. On a Mac, Command-Option-I will give you a code chunk. So what I wanted to do now is kind of demo some of the options real quick to show you what the output looks like when you specify a particular option. So here on the left-hand side, I have some code, and I have the option label. So I'm going to label this xorgs. And then I also have this echo option here, and I'm going to label this as true. And what I'm doing is I have an object called x, which is 1 through 10, and then y, which is 11 through 20, and I'm just plotting x and y. When echo is true, it's going to show the code, and it's also going to show the result as I have highlighted here. If we say echo equals false, what we see is that there is no code output, but it outputs the figure. Eval controls whether the code is executed or not. So using the same code, if we say eval equals true, what we see is that it outputs the figure, but not the code. And if we say eval equals false, it does not run that code. It does not produce a plot, but it will output the code. And you don't only need to use one option, you can use several options, and I'll show you how to do that in the little demo here. One cool thing that you can do when you render to HTML is you can actually hide the code, and you can show it when you want to. So there's an option called code fold. So it looks like this. Equals true, and that will allow you to basically have an interactive code chunk that you can collapse if you want to, which I think is really cool. All right, so what I want to do is walk through a code chunk exercise. So what I'm going to do is I'm going to use an R script, and I'm just going to copy and paste some code into the document that we've been working on. So to find that, what we need to do is go back to our website and then go to the GitHub repository. So I have a folder in the GitHub repository called slides. So let's click on that. Oh, excuse me. Sorry, not slides. It is in scripts. So go to scripts folder, and then there's this dummy.r file. Let's click on that. And I have some code in this file. So we're going to be loading some packages, and then we're going to be plotting something. So let's go ahead and just copy this. Actually, let me just download this and load it into there. Okay. I'm gonna load this into, so let's go ahead and use our document. So I'm just gonna call code. All right. So I'm gonna go to the source editor. And let's go ahead and create a code chunk. So we're gonna use the backticks and then the curly brackets are. And then remember that you have to have backticks at the beginning and the end, and that will create a code chunk. And here what we have is we're just loading some libraries, but let's go ahead and label this code chunk. So let's do label, and then let's call this just read in packages. And then let's just do echo equals true. Let's say that we want the code chunk to be present in the manuscript itself. Let's go ahead and render this document and see what it looks like. So we see in the code section here, we have load packages, and we have our code here that shows what packages we are loading into our session. Awesome. So let's go ahead now and let's plot some data. So let's go ahead and label this. So let's say label, let's say this is plot figure. And let's say that we don't want this code presented in the manuscript. So we're going to say echo equals false. So we render our document here. We see we have our code here, and then we also have our figure here, and there's no code associated. We set echo equals false. So we can add other elements to this code chunk. So we can actually change the width of it. So let's say that we want the width to be 12 and the height to be, let's say the height equals to be 8. So we'll render that, and we can see that the figure has been changed. We can also add a caption if we want to. So let's say figure cap. Let's call it, let's say penguin plot. If I can spell. Something like this. And this will caption the plot. So this is how you insert code chunks and how you can add certain options to your code chunks. Again, there's a whole bunch of options that you can use. I'm barely scratching the surface of what you can do. But I think this is a nice little highlight of what you can do. So what I want to do now is with the rest of our time is to talk about inline code and then how you can render your document. So inline code is probably one of the most important features because it allows you to take the code chunks and allows you to reference those in text without any type of additional formatting. So why might you want to do this? Well, it allows you to report and describe results reproducibly. It minimizes error, so you're not copy and pasting. You're not going from one program to another. You're just doing that within the actual same document. And you can also automatically update when the data or code changes. So in order to use inline code, we need to use an R expression, which I have highlighted here, which is just a backtick in R. And this is just like an example of code that we would use. So this is from the cars data set, which is standard, so it comes with base R. But what we're doing here is we're using this R expression here, and we're counting the number of rows in that data set. And this is the output for it. So it tells us that there's 50 observations in our data. What's important to note here is that you can't use the source editor or the visual editor to automatically render this or preview this. You have to actually render the document to see the change. So if you put this into your document, it's not going to automatically update. You have to render the document. As another example, we can have objects that we reference in text. So here I have X, which is the values 1 through 10, and I'm taking the mean and standard deviation of that. And then this is what we're writing in text, where we have some formatting here, and then we are using this R expression to output the mean and standard deviation. And this is what the output looks like. So the mean is 5.5 and the standard deviation is 3.02765. If we wanted to, we can actually just use the round function within the standard deviation object to only output up to 2 decimals if we wanted to, which I think is really cool. And this is another example where we're taking the penguins data set and we're just counting the number of Adelie species in that data set. And you can see here that there's 152 penguins of the Adelie species in the data set, which is super cool. So real quick, I wanted to highlight how we can incorporate inline code into our manuscript. So I'm going to do a really quick example highlighting how we can just insert a correlation between 2 variables. So we're going to insert a code chunk here.
So yeah, there was one of the questions was how to insert the code chunk. So if you could just walk us through this maybe a little bit slower and just make sure people understand.
Yep. So what I'm going to do is I'm going to take this penguins data set and I am going to remove all the NAs because the correlation function will not work if there are NAs. omit. And then what we're going to do, let me just make sure that this runs. There we go. So what we're going to do is just use the core function. And what we're going to do is we're going to look at two variables from the Penguins data set. So let's look at bill length, and let's look at bill depth. So let's assign this to an object. Let's say Penguins core. Let's see if Penguins core produces something. Yeah, so we have a correlation here. So how can we reference that in text? So I created this code chunk here. It's bad form. I didn't label it or anything. But what we can do is I can say I conducted a correlation between bill length and bill depth. And I got a correlation. So we can use R notation here. So I'm just formatting this so it's italicized. Equals, and then I'm going to use this R expression here. So you have to use the backtick R, and then you can reference this object that we created here. Right? But as we can see here that it goes out to a lot of decimal places, so I'm going to use the round function. And I'm going to output up to 2 decimals. So I'm just going to use this. So this is how we can reference in text by using these R expressions here. And this is not going to run because it is not spelled right. There we go. So let's go ahead and render this document to see what it looks like. So I have inline code here. I conducted a correlation between bill length and bill depth, and I got a correlation of R.23. Awesome. But maybe I want the code displayed, so I'm just going to do echo equals true, so we know what the code looks like. There we go. So now I have the code here, and I also have the output from that code here. So this is an example of how you would do inline referencing of your code chunks. Does that answer that person's question?
Yeah, I just asked that as well, so I'll just wait for an answer.
Awesome. Yep. All right. So with the remaining time, what I want to do is I want to talk about rendering your document. So let's go back to that. Awesome. So with Quarto, you can output lots of different formats. So you can output your manuscript to HTML, to PDF. There's a new format called typest, which I think is better than LaTeX. So in the next couple of years, I think that more people are going to be switching to typest. You can output your format to MS Word, OpenOffice, EPUB, lots of different options. And there's several different ways that you can render your document. So I highlighted one way, which was to just click on the render button in RStudio, right? So just click on this render button, but there's other ways too. So I asked you to download the Quarto package so you can render your document within the console itself by using the Quarto function, as I have highlighted here, Quarto rendo. But you can also use the terminal within RStudio. So there's a terminal panel, and you can just run Quarto render, and you can render your document if you want to. And you can render your document to different formats, but we have to make sure that we add the key into the YAML here. So I have highlighted here different values that we can use for format. So HTML, PDF, Word. If we go back to our document here, let's just add that to there. We can do format, and I can do HTML, which we've been doing, but that's not fun. So let's just do let's do docx. So I can render this document into a Word document. And I don't have Word on this computer, but I have Pages. So let's see how this opens. Okay. So again, we see this is a Word document that I just created, and it has, my code, and it also has some references here. We can also do this to PDF by just changing the format to PDF. So this is a PDF document that is rendered. So again, you can render to multiple different formats here. And one note that I wanted to make is that if you use the render button in RStudio, you can only output to one format. If you use the terminal to render your document, you can output to multiple formats. So sometimes you might want to render to Word, HTML, and PDF. You can do that within the terminal itself. So if you do Quarto render the document, if you have multiple options like this. So if we rendered this in the terminal, we can output to PDF and Word. However, if we just click on the render button, it's just going to output to the first default here. So just to make note of that. But you can render to multiple formats if you desire. There's also lots of really cool templates that you can use and borrow from. So this is just a handful of them. One that I wanted to make everyone here aware of is the APA Quarto template. And one thing that I hate more than Word is formatting an APA document. So this APA Quarto document template pretty much just makes your life a whole lot easier. It has a YAML, and it also has some other additional extensions included in it that will just render your document for you in APA format. So everything is already done for you. So I highly recommend using the APA Quarto template when you're writing your manuscript. This is just an example of what some of the documents look like. So this is just an APA title page, but this is formatted automatically for you. And then this is also an additional way that we can output it as a journal template. So the documents just look really, really, really nice. So please look into APA Quarto if you're writing an APA manuscript. So since we're out of time and I want to leave some time for questions, I'm not going to talk really about publishing, but there's lots of different ways that you can publish your work. So you can put it on OSF, you can put it on GitHub, or you can create a website with the HTML document that you can share with collaborators. But I can also answer questions about that in the Q&A. But I want to leave some time for questions. So what do folks have for me?
Okay, well, that's been a very interesting and informative presentation, Jason. So thank you for walking us through your whole workflow. Super useful, and I'm sure other people will also use this sort of format to improve their workflow in the future. We have one question from Catherine Moore about using this sort of Quarto document when collaborating.
Yeah.
So I can imagine that you say you write up a manuscript and you send it to some old professor, and they're familiar with dealing with manuscripts in editor mode in Word. Is this going to totally mess everything up for you?
No, not necessarily.
No?
Not necessarily. So this is a question I get asked very frequently. So what you can do is you can render the manuscript as a Word document and then send that to the old professor, and then they can make their edits, and then you can incorporate it into the Quarto document. However, there is a package called Trackdown that allows you to take Markdown and allows you and converts it to a Google Docs. So you can actually basically take your Quarto document, turn it into a Google Docs, and then you can re-download it with all of the changes that a professor provides. So there's ways around this. Ideally, you would want them to work in Quarto and do push and pulls from GitHub, but that's not always the case. So my recommendation would be to either just give them a Word document, let them edit it, and then incorporate the changes into the manuscript itself, or take your Quarto document and render it to Google Docs using Trackdown. have them provide their suggestions and edits, and then just re-download that Quarto document into your console. Would probably be my suggested workflow for that.
Another thing that she kind of
Step.
mentioned was using Google Docs instead of Microsoft Word. Is there also some compatibility there, or is this
Yeah, so the trackdown allows you to take your Markdown folder, your Markdown manuscript, and allows you to like place it on Google Docs.
Okay.
With Markdown and all that stuff already preserved. So they can make changes for it, and then you can actually re-download it. So within using the trackdown package, you can actually push your manuscript to Google Docs from the R console, have them make changes to it, and then you can re-download it from Google Docs into your actual project folder, which is really cool.
So Catherine adds, it sounds like the difference between these options is that with trackdown, you can actually collaborate, whereas rendering as Word, you'll have to see the edits and incorporate them yourself.
Yes. Yep.
So, a little bit more work.
Maybe in 5 or 10 years that, the landscape will change. There's no appeasing everyone.
Yeah.
But hasn't been too bad.
Any further questions from the audience? Otherwise, I can ask some questions. Yeah, so we get a thanks from the audience. So maybe while people are thinking of their questions, I can ask, do you already have some examples online of completed manuscripts that people can look at to see kind of the end product?
Yeah, so I have I have several manuscripts that I've used the APA Quarto template that I can share definitely. So let's go. So I use GitHub. Definitely recommend it. Let's go to. I'm just gonna go to my repositories. But I'm just gonna. So this is a repository that I have that actually has the manuscript file. So this QMD document. So I'm going to post the URL for this, but this is a completed manuscript that will render it into APA format, and then it renders it into multiple formats like PDF and HTML.
Awesome. Could you screen share so we can see that?
Oh, let's see here. I guess I stopped screen sharing. There you go. Personal screen share. There you go. So this is a manuscript that I recently got published. It's done in APA Quarto. So you can see this YAML here has everything that you would need in an APA format. And there's also other files and folders that come with APA Quarto that help with this. But yeah, so this is a completed manuscript and I can link to this. This is open. So I will link to that in the chat if people are interested in it, and you can fork it if you want and then use it for your own manuscript. But if you download the APA Quarto template, it will come with a template for you to add to too as well.
Very nice, super useful. So I presume that nowadays, anytime you publish a paper in the OSF, then you also include a link to all this GitHub.
Yeah, so sometimes I'll link my GitHub repository depending on like how big my data is. So here everything is pretty much on GitHub, so the manuscript documents, and then my OSF has like my stimuli, the word list, stuff like that. So that's how I've been doing it, at least.
Very cool. And another thing that I was kind of wondering about, so sometimes I make figures that I can interact with live. So for example, you can make a surf plot that you can rotate in three-dimensional space.
Yep.
Is this something that you can then incorporate into a Quarto manuscript so that you can continue interacting with it, or does it have to be rendered into the manuscript itself?
So there's lots of flexibility when you render to an HTML document. So you could have like a Shiny app within the HTML document, right, where people can interact with whatever you want them to interact with, and search through a database and plot certain things. So you can add, there's lots of flexibility in that regard. So if you have some type of object that you want people to interact with, like be able to move it, you could do that with an HTML document. Obviously, you can't do that with something static like a Word document or a PDF document, but as you see here, I have this hosted on a web page, and this is the document that I submitted for publication that I share with folks. So there's lots of cool stuff that you can do with it.
Awesome. Yeah. And I think there's some publishers that are now kind of experimenting with a little bit more than just the static images for their figures.
Yeah.
So maybe this will catch on in the future.
I hope it catches on.
Yeah.
Yeah, no, there's lots of really cool things that you can do. So there's actually a thing called WebR that allows you to insert actual like interactive code. So like you can run all of this code from the HTML site, from the document itself, and it produces output, which I think is really cool and useful. So it might render the journals kind of obsolete because you can do so many cool things on your own by just hosting it on your own web page.
Yeah, and I guess because we are, it has been quite a long workshop already, but maybe we can finish off with, and I think Catherine is kind of on this idea as well. Just kind of a speculative note from you. How do you think journals are going to be changing in the future as people are kind of becoming better at formatting these themselves, or having more ability to, when you make your own manuscript, to have lots of interesting things? Does this essentially make the current journal model more or less obsolete?
I mean, again, it depends on who you ask, right? So I have some collaborators that are like, you shouldn't even be publishing in journals anymore. Just post preprints, and post links to your web page and have those be interactive. My hope is that the journals will go towards more computational reproducibility and interactive code chunks. So something like this, where individuals can actually see all of the code. So here I have this code chunk, right? So you can choose to see the code or not, right? So you have that option, but you can also interact with it and run the actual code yourself. That's my hope. Do I think that's going to happen? No. And the reason why is because I think you'd have to pay people to actually format the documents like this. And I don't know if they're going to do that, unfortunately. But my hope would be that you'd get something that like this, like I'm showing you right now, where you can show the code, but also have the added interactivity of running the code itself.
Yeah, I guess we'll have to wait and see how the future unfolds. But
Yeah, we'll have to see how the future
exciting time.
unfolds. But I don't know. I don't know if you've ever submitted to a journal that has code in it and that you want displayed in your manuscript, but it's absolutely horrendous. They usually place it as an image, and you can't copy and paste. And yeah, so it makes reproducibility hard in that sense. Yeah, here I can just copy the code and run it if I want to. So
yeah. Unfortunately, I think that the pace of science is faster than the pace of journal editorial advances, or maybe that's a good thing. I don't know. In any case, I think I'm going to stop the recording in just a moment.
Awesome.
But before that, I wanted to say thank you again, Jason, for this very interesting talk. And thank you for allowing us to record this and keep it online so that people
no worries.
can also
Thank you for inviting me to talk about this. Hopefully, that's useful to some of the individuals in this chat and in this talk. And also, too, if you have any questions, feel free to reach out to me. I'm always open to answer questions and difficulties you run into. So please reach out to me if you have any questions.
Fantastic. Then I'll stop the recording, and thank you again, Jason.